Hello friends, welcome to the second video on Green's theorem in a plane. In the first video, we saw about the rectangular region for which we verified the Green's theorem. In the second theorem, we will be trying to plot or verify the Green's theorem in the xy plane for the given function, where C is going to be the boundary of the region given by x equal to 0, y equal to 0 and x plus y equal to 1. So we will see what this figure holds for us, and we will see how we can verify Green's theorem in the xy plane. Whenever the concept is to verify, we will have to evaluate our left hand side separately, evaluate our right hand side separately, and we'll have to show that both the values are going to be one and the same for verification to be true. So the statement of the Green's theorem carries the first primary mark for us. So state your Green's theorem. By Green's theorem, integral over C p dx plus q dy will be equal to double integral over r dou q by dou x minus dou p by dou y dx dy. Now let us move on to visualize the region which has been given to us. We have been said that the region is going to be marked by x equal to 0, y equal to 0 and x plus y equal to 1. So I'll have to plot the lines x equal to 0, y equal to 0 and x plus y equal to 1. So how to go about it? This is going to be, say suppose we have the axis drawn, your y-axis as well as the x-axis. So now let us going to move on to plot our values for the quantities x equal to 0. Which is my x equal to 0? My y-axis represents my x equal to 0. And which is my y equal to 0? My x-axis represents my y equal to 0. So first let me draw these two lines for us. So this is going to be the line, first line which is given by x equal to 0 and next line which is given by y equal to 0. So we have this line to represent y equal to 0. So the first two lines have now been fixed for the evaluation x equal to 0 and this is y equal to 0. So now going for the third line, which is my third line, x plus y equal to 1. How to get this line or plot this line? Now substitute the above values over here, put x as 0, then what you get? Y as 1. So 0 comma 1 is going to be 1 point. And when we put y as 0, what we get? X is going to be equal to 1, 1 comma 0. So this curve or this line is going to pass through the point 0 comma 1 and 1 comma 0. So let me plot the point. This is 1 unit over here. So this is my x equal to 1. So this gives me 1 comma 0. So in the same distance, let me also plot 1 over here in the y-axis. So this makes me x is 0, y is 1, so 0 comma 1. So I now need a line that is going to pass through my 0 and my 1 comma 0. So this is going to be my line which is going to be given as x plus y equal to 1. So now this is going to be the origin O. Let us name it as 0 comma 0. We know that the curve C which has to be traced has to be measured or traversed in the anti-clockwise direction. Anti-clockwise meaning in this way. So I'll have to trace my curve C in this direction. In which case, let me begin with O. So let me go along the line O and let me mark this point as A, O, A, and let me mark this point as B. So next I move along my line called as A, B, and after reaching my point B, I move downwards traversing along the line BO. So I can write in this simple format my integral along the closed curve C, which is in my left hand side, can be split and written as three integrals along the line OA, along the line AB, and along the line called as BO. So instead of evaluating a single curve, we are splitting it into three parts and evaluating them separately, and adding up them will give us the same answer as the prior one. So let us move on to fix what are going to be these lines. First line O along the line OA. What is the name of the line OA? The name of the line OA is y equal to 0. So y equal to 0 over here. And what is the name of the line AB? The name of the line AB is x plus y equal to 1. Next, the name of the line BO. The name of the line BO is going to be over here. this line is going to be called by the name x equal to 0. So when I am evaluating all these three integrals separately and adding up them for this curve called as see this expression p dx plus q dy, then we are done with the left hand side of the quantity. So come on, quickly we will move on to estimate these three curves, for which I will first copy what is going to be the evaluation which is going to be required over here. So the integral is integral along the curve C. The function to be evaluated is going to be 3x square minus 8y square times of dx plus 4y minus 6xy times of dy. Now the first curve is going to be along the line called as OA. Now what is going to be my line OA? This is my line OA. What is the equation of the line OA? So the equation of the line OA is given as y equal to 0. So for this, let me fix if my y equal to 0, then what can we say about the derivative? The derivative dy will also be equal to 0. Let us apply these two quantities in the given expression. This will simplify the value into a next level or an easier way. So we substitute the quantities y equal to 0 over here and dy equal to 0 over here. So y equal to 0 implies dy. When these quantities are substituted, dy equal to 0, what will happen to the second term? The second term which is present over here, which has dy over here at this part, will entirely vanish, moving towards 0. Now y equal to 0 over here. See over here we have a y. So what will happen to this term? This term will vanish. And we will be just left out with the integration along the curve C. 3x square, this is gone, dx will be there, and when we substitute y equal to 0 or dy equal to 0, dy equal to 0, 0 into something, this entire term will vanish. So this is my left out for my curve OA. So I have this to be equal to 3x square dx, 3x square dx, the left out quantity. Now in which direction the variables are present? The variables are present in the direction of x. Now come on, see what is the variation on your x. So my x varies from, what is my starting point of x? My starting point of s is going to be 0 over here. My starting point is 0 over here. As I move along the curve OA, I reach the ending point of x. What is the ending point of x? The ending point of x is got as 1. So it becomes clear that my x varies between 0 to 1. Hence, I can evaluate 3x square dx from the curve 3x square x cube by 3 between the limits 0 to 1. So that makes it as 1. So my first division along the line OA, the answer obtained is going to be 1. Now let us move to the second part. Now when we move to the next part, we are moving along the line AB. What is the name of the line AB? X plus y equal to 1. So we have x plus y equal to 1. So we will have to convert it into one variable because I have only one integration. So we will see which is going to be the best. The most preferable value is going to be, I have y to be present over here. I have x to be present in 2 times. So let me replace my x as 1 minus y. When I replace my x as 1 minus y, what will be the derivative dx? Dx will be equal to minus dy. So I resubstitute these two quantities in my above expression. So my integral along the curve, this curve is now become, the C has now become AB. So my integral along AB now becomes equal to 3 times of x square. So it becomes 1 minus y the whole square minus 8y square into this dx will now be replaced with minus dy. Next comes plus 4y minus 6. How to replace this x with? This x to be replaced with 1 minus y times. You have one more y over here, and this has to be entirely integrated with respect to dy. So I have this to be equal to integral of, you have the limit in the direction of which variable, now it has now turned out to be in the direction of y. Now come on, let us check what is going to be the limit in the direction of y. So your y begins your journey with 0 as it moves upwards, traversing the line AB. Where does your y end? Y ends with 1. So my limit for my y variable will be from 0 to the value called as 1. So you need to keep in mind this can also be done by converting the value for your x. Instead of x, I can replace y as 1 minus x, and this dy can be replaced as minus dx, in which case all the variables will now turn out as x. So you will have to fix your limit for x. What will be x varying from? X will vary from 1 to 0 as we move in the anti-clockwise direction. So be very careful when fixing the limits. Now since my direction is for the variable y, where does our y vary? Y vary between 0 to 1. The function to be simplified is 3 times of 1 minus y the whole square. So I make it as 1 minus 2y, and this becomes y square, and this is going to be a minus sign over here. So attach this minus sign to minus will become plus. This is going to be 8y square, and I am taking this dy outside. So the next term becomes 4y. The next term becomes minus 6. This is a y over here. So it is minus 6y. Minus into minus will become plus 6y into y will give us y square. This entire quantity has now to be integrated with respect to the variable called as dy. On simplification, we can notice that this gives the value as minus 3 with respect to y, minus into minus plus 3 2s are 6, y on integration gives you y square divided by 2 plus, sorry, it is going to be minus sign of 3 times y square on integration is y cube divided by 3 plus 8y square y cube divided by 3 plus 4y square divided by 2 minus 6y square divided by 2 plus 6y square is y cube divided by 3. The limit to be applied is going to be between 0 to 1. Apply the upper limit 1 and lower limit will automatically become equal to 0. So this now turns out to be equal to minus 3. The next term is going to be plus 6 by 2 plus 6 by 2. The next term is going to be equal to minus 3 by 3 minus 3 by 3. The next term will be equal to plus 8 by 3 plus 8 by 3. The next term will be equal to plus 4 by 2 plus 4 by 2. The next term is minus 6 by 2 minus 6 by 2, and the next term is going to be equal to plus 6 by 3 plus 6 by 3. Let us simplify these quantities now. So this on simplification gives me minus 3, this goes plus 3, this goes minus 1, plus 8 by 3, this goes 2 times, this goes minus 3 times, and this goes plus 2 times. So you have it to be equal to minus 3 and plus 3 can be cancelled off. Minus 3 and minus 1 will make it as minus 4. Minus 4 and plus 2 is plus 4. It cancels off, leaving you with the second curve answer as integral along AB as 8 by 3. Now two curves are over. Let us move to the third curve. What is going to be the third curve? Integration along the line BO. What is the equation of the line BO? Equation of the line BO is x equal to 0. When x equals to 0, what can we say about the derivative dx? Dx will also be equal to 0. So substitute x equal to 0 and dx equal to 0 in the base curve equation. So you have integral 3x square. So this will become 0. Dx, this dx part will vanish entirely, this quantity. Now 4y will be remaining, and this x is replaced as 0. So this will vanish. So we are left out with 4y dy. So the long expression over here has now become a very, very short expression by diminishing all the quantities by applying the required conditions. Now to check for the limit of y, now we'll have to be very careful when we move in the direction of y. From where to where we move from B to your point O. Which ordinate to be checked? We have to check for the y coordinate. Y varies from, it starts with 1 and it ends with 0. So where does my y vary? My y varies from, y begins its journey at 1 and it ends at journey at 0. So don't take it in the common sense like 0 is the lower limit and 1 is the upper limit. You will go wrong because we are traversing the curve in the anti-clockwise direction. So y when it comes down will move from 1 to 0. So let me integrate this. This is going to be 4. y square divided by 2 between the limit 1 and 0. This goes off 2 times. So we have 2 times of 0 minus 1. Hence the answer is going to be minus 2. And this is along the curve called as integral along the line BO. So now for me, the integral along the curve C is the addition of the three parts OA plus integral along AB plus integral along BO. Let us move on to accumulate all the three values. The first curve along OA, what was the answer got? Answer got was 1. So the next curve was 8 by 3 and the third curve was minus 2. So this makes it as 1 plus 8 by 3 minus 2. So now this makes it as 1 minus 2. So it is 8 by 3 minus 1. So when we subtract 3 as LCM, you have this to be equal to 8 minus 3. So 5. So integral along the curve C is going to be 5 by 3. So my answer for my left hand side is going to be 5 by 3. So the quantity now to be evaluated is for my left hand side. And what is going to be my left hand side? So come on, let us go and copy or see what is going to be the Green's theorem for my right hand side. The right hand side says that we have double integral dou q by dou x minus dou p by dou y dx dy. So we need to evaluate what is the partial derivatives of q and p with respect to x and y. So let us begin with the partial derivatives of the values over here. Now identifying the question with the given Green's theorem statement, what do we notice is in place of p, what do we have over here is 3x square minus 8y square. And what do we have in place of q? We have it as 4x minus 6xy. So we write the value for p to be identical with that format as 3x square minus 8y square. And the value for q, which is identical with this format, is going to be 4y minus 6xy. So now I want dou q by dou x, q with respect to the variable x. So this 4y will become 0 minus 6xy will give me 6y. So now moving with the second part, dou p by dou y. Differentiating with respect to y, this will become 0 and I will have this to be equal to 8 2s are 16 times of y. Now the question is to evaluate dou q by dou x minus dou p by dou y. So the first term is going to be minus 6y minus the second term is going to be minus 16y. So this gives me minus 6y plus 16y. So this leaves us with 16 minus 6. So this is going to be 10y. So I have double integral over my r. The function over here, this part is going to be nothing but 10y dx dy. Now coming to the main part, this is going to be the region along which we are going to evaluate the integral. So this is going to be the region of my integration, the triangular part, which is going to be encircumferenced by the curve C, the closed curve C, which has been given to us by the boundaries x equal to 0, y equal to 0 and x plus y equal to 1. Now how to fix the limit for r? I can fix it either in the direction of x or in the direction of y. Let me fix it in the direction of x. If I fix it in the direction of x, draw a line parallel to your x-axis. If you draw a line parallel to your x-axis, then what happens? My x begins over here at the point x equal to 0. So we have this as integral x beginning the journey with 0. What is going to be the ending point of x? The ending point of x is got as 1 minus y. So I have it as 1 minus y. So my x varies between 0 to 1 minus y. Now how about the limit for my y variable? Where does my y vary? Y varies from bottom to top. So what is the bottom point? Bottom point is 0, 0. What is the top point? Top point is 0, 1. What is the variation of y? Y varies from 0 to 1. So y varies from 0 to 1. So what is the function to be integrated? 10y dx dy. Now we are ready for the integration. So the region integration R is nothing but integral y varying from 0 to 1, our x varying from 0 to 1 minus y, 10y dx dy. Since the integration is first carried out with respect to x. What happens? 10y remains to be a constant. We have x on integration to give us dx on integration give us x, and the limit to be applied is 1 minus y. Still we have to carry out the integration between 0 to 1 with respect to dy. So this now gives me 10y, and this gives me 1 minus y with respect to dy, integral between 0 to 1. So it is going to be 10 y on integration is y square divided by 2. So let me integrate the second term, minus y square on integration is y cube divided by 3. The limits to be applied are from 0 to 1. So now taking the value over here, let us split this page into two parts so that it will be easy for us to work out the things. So now moving on to the substitution and the simplification of the limits. 10 times of this is going to be 1 by 2 minus 1 by 3. The lower limit now vanishes. It's 10 times of 2 3s are 6. So you will have 3 minus 2. So that makes it as 1. So it is going to be 10 divided by 6 on simplification with 2. You have this to be equal to 5 times, and 6 goes how many times? 3 times in your 2. So we have arrived at the region integration, which is going to be my right hand side, as 5 by 3. So we will check whether the left hand also has been arrived as the same one. So we can go to my left hand side and we see that left hand side is also the same 5 by 3. So we conclude that the left hand side and right hand side are going to be the same. Hence we have verified the Green's theorem for the triangular region given or bounded by x equal to 0, y equal to 0 and x plus y equal to 1 for the given function which has been defined along the closed curve C. Thank you.